Yes, hello, Arnav. You were saying something?
Yes, ma'am. You had once given us a question in which we had to find the derivation dimensions of neta. Sorry, eta.
This one.
No, no. It was a little back. I think last to last class.
Okay, eta, yes, yes. The coefficient of viscosity, that one.
Yes. I just wanted to ask what will be the SI unit of eta, because if you try to find it out, it's nothing.
Just a second. This one, no?
Yes.
Okay, see. If you try to find out the SI unit, it will come out to be. See, actually the SI unit of this coefficient of viscosity, it is decapoise. That is some value that is you should not know right now. But if you are asked to find out what is the coefficients, SI unit or what is the CGS unit, if you are asked, then what you can do, what is the formula coming? Force multiplied by length divided by area by velocity. So write all the SI units of these. For force, it is Newton. For distance, it is meter. For area, it is meter square. For velocity is meter per seconds. So meter gets cancelled. It becomes Newton second per meter square. So this will be the SI unit of it. Clear? In this manner, you have to write. Otherwise, in fluid mechanics, you will be studying in detail where you have it decapoise and poise, and then you know the conversion of it. But if you are asked SI unit, writing this much is also sufficient. Did you both try the question that I gave you? You had to find the fundamental unit of length, mass, and time. This question I gave you as a homework in the last class. A fundamental unit of force is 100 Newton, velocity is 10 meter per second, and time is 10 seconds. Then you had to calculate the fundamental units of length, mass, and time. Did you try, anyone? Aram, what about you?
Yes, ma'am, I did.
So what's the answer that you're getting? Let's discuss it then.
10 raised to 5 kg. Is it correct?
Mass. How much, Aram? Just write me down. Just write it down in the chat box. That will be better, I think. Whatever answer you were getting, until the time, let's discuss it. See, fundamental unit of force is given to you as 100 Newton. What is the dimensions? What are the dimensions of force? mLt to the power minus 2. How am I writing this? Mass multiplied by acceleration. Acceleration is velocity by time. Velocity is distance by time. So in this manner, you can keep on writing. This whole is equal to 100 newtons. Then velocity is what? Distance divided by time, means t to the power minus 1. This is equal to what? 10 meter per second. And then you have time. So time's dimension is t to the power 1 only, which is 10 seconds. Now, if you put in the values of time in velocity's equation, just to check it, if you put the value of time in second equation, let's name these equation, then it will be easier. Let's say this is equation 1, this is equation 2, and this is the third equation. So if you put 3 in 2, see what you will get. L to the power 1, t to the power minus 1. So t is what? 10 to the power minus 1. T to the power minus 1 is 10 to the power minus 1. This much is equal to what? This much is equal to 10. So if I write it L by 10, this minus power becomes what? Plus 1 power. This is equal to 10. So length becomes what? 10 multiplied by 10, that gives me 100 meters. In this manner, you have to calculate. The way you have no linear equations with 1 or 2 variables, how do you calculate? By substitution method. You take out the value of one variable from one of the equations, then you put it in the other equation to find out the values of the other variables. Similarly, in this also, you have to first write down the equation and then put the value of one variable. So in this case, variable is to you what? All all length, time, and mass, all these are variables. 3 variables are there. You are getting 3 equations, so you will be able to solve. So if I put the value of time, I can get length. So length is clear. So now I have one length with me. Time is already 10. So T is also there, length is also there, and you had to find out mass. So one is missing. So if we put the value of, now we have the value of length, we have the value of time. We do not know force. So let's put the values of length and time to get out the value of mass. MLT to the power minus 2 is equal to 100. So M, we don't know. L, 100. L to the power 1 was there, no? So this is correct. T to the power minus 2. This is your whole dimensional formula. This is your dimensional formula that is coming. This is 100. This is 10 to the power minus 2. This is the whole dimension formula that is equal to 100 Newton. Now, M into 100 divided by 100. This is equal to 100 Newtons. So 100 gets cancelled. Mass also comes out to be 100 kgs. You have the values of mass, you have the values of length and time together. Time was already given 10 seconds. So there wasn't any need to calculate it. Just note it down. You already have the questions. Aram, what was your answer coming? Was it this only, length 100 and mass 100 kg? Aram?
Ma'am, length is correct, but maths, it was.
Okay. There was some error in mass. Okay. I know you also note down the questions. And I want to ask you both. I have checked your assignments. There is no assignment submitted by you both. There's not a single assignment you have submitted. We have given you so many assignments. Whole dimensional analysis has come to an end now. You people haven't submitted. What's the reason, Arnav?
I was busy with schoolwork.
See, there are hardly 4 to 5 questions. I'll do one thing. In today's assignment, I'll give you only 3 questions. But promise me that you both will submit the assignment today. Only 3 questions I'll give, not even 5 or 6, the amount of questions I'm giving you. Easy 3 questions that will be based on either dimensions or whatever we'll discuss today. But you both will submit. Aram, what about you? No assignment from your side till now?
Sorry, ma'am, I'll submit it.
All right, please try to submit it. See what happens. Whatever we discuss in the class, now that is only there in the assignment. If something is extra, that we will discuss. But in order to discuss that, we should know what you all have tried by yourself. So yeah, last class assignment had few questions that were tricky, that you might have not heard of, or that we have not discussed in the class. So I wanted to discuss the assignment, but when I looked at the updates of your assignment, there wasn't any assignment submission by you both. So in today's class, in today's assignment, I'll give you very few questions, only 3 questions, but make sure that you both submit all the 3 questions so that we can discuss it in the next class. Okay, so note it down. Then I'll discuss the previous assignment because it had few questions that we had not discussed. Done?
Yes, ma'am.
Arnav, written?
Yes, ma'am.
All right. So let me discuss that assignment that was given to you. See, this was your assignment. Please try to do it. All the assignments, try to. So this I am discussing with you. See, this is your first question. The device used for measuring the mass of atoms and molecules. This is what? Spring balance, torsional balance, mass spectrograph, common balance. So the answer of this is mass spectrograph. Mass spectrograph is used to measure the mass of atoms and molecules. And the second question that was given to you, it was, which is the incorrect statement regarding mass? So it's the basic property of matter. Correct. It's the basic property of matter, or you can say it's the intrinsic property of matter. Means it is fundamental property that we have studied. SI unit of mass is kg. We have seen. And what is the CGS unit of mass? Yes. Yes, Arnav.
Mass is gram.
Grams, correct. Mass is grams. So SI unit, mass of an atom is expressed in terms of U. This you must have studied in your chemistry. You will study it. AMU, atomic mass unit. Fourth
Ma'am?
part. Yes, Arnav.
I didn't receive this. I just received the first assignment. I didn't receive any assignment after that.
You haven't received it on your WhatsApp or on the Learnivio app.
Yes, ma'am. I just checked the WhatsApp. There's no other assignment.
There's no other assignment. Okay. Then I'll contact them why the assignments haven't reached you. What about you, Aram? Are you receiving the assignments?
I just have the first.
Ma'am, only one I've received.
Not the second and the third one. This is the
No.
third assignment.
No. Only the first one I've received.
All right. I'll ask. I'll just check the Learnivio app also. We have a new student today. Mushahid.
No, ma'am, it's Fahad. I haven't renamed it. Fahad Siddiqui.
Okay. Fahad. Fahad, you had a class with me, no?
Yes, ma'am.
Okay. All right. Fine, Arnav, Veram, I'll let you know. But I'll make sure that you receive today's assignment. And try that. I'll give you only 3 questions, so that you should be able to do. Then the third question says one unified atomic mass is equal to. So instead of calculating it all the time, these 3 questions are not so important. That's why I'm discussing it, so that you get rid of all these questions and no need to go into the details. This is 1.66 into 10 to the power minus 27 kgs. Now 10 to the power minus 3 grams is called what? Milli. Wherever you get the term 10 to the power minus 3, whether had it been 10 to the power minus 3 meters, it would have been millimeters. Wherever you get the term 10 to the power minus 3, that is always replacement of the term milli. So if it's 10 to the power minus 3 grams, it is milligram. And if the value of force is 100 Newton and the value of acceleration is 0.001 meter per second square, what is the value of mass in this system of SI units? See, F is equal to what? MEA, I have told you in the formula, the whole dimensional chart that you have written, F is equal to MEA. So from there, you know A, you know F. Then calculate the value of M from here. So I think the answer will come 10 to the power 5. So I'll make sure that you get both the assignments as well. The assignment number 2 and assignment number 3. So Fahad, we are done with the dimension analysis. So right now we are starting with error analysis. So if you have any doubts regarding dimensions, you can ask me. Otherwise, error analysis is a new topic. You will be able to understand it. So backup you can take on later. Fine, Fahad?
Okay, ma'am.
See, error analysis is an important topic, not only from your theoretical paper, but from your practical papers as well. In practical exams, error analysis is one of the major tasks that is difficult to accomplish. Error analysis means what? See, you have various instruments. in laboratories also, if you have had your practical classes, you must have heard of these Vernier Calipers, screw gauge, and all these instruments. Even if not them, leave them apart. You have your scale with you, the scale with the help of which you measure things. So even that scale, any quantity that helps you to measure other quantity. For example, watch. You have watch with you, your wrist watches. If you look at the wrist watches do what? They measure time. So that's also a device. It can also have error. Meter scale, if there's some calculation error in there, or we have done the wrong reading, so there is error in there also. And then all the experiments, instruments that you have, like the Vernier calipers, because of wear and tear, the instruments also get used up and they show error. So there can be various reasons for error, but for finding out the error and to choose which instrument is best suited for us. See, there are various instruments available. If I want to know the diameter of a ball, I have a very small, let's say, bob with me. Bob, you must have heard of. A bob is a very small ball-like structure, metallic ball, if I say. Then I want to find out the diameter of that small bob. Just a diameter of that very small bob, this much size bob, and I want to find out the diameter. If I take my meter scale, no, with the help of my meter scale, those or the centimeter scales, you can say, which you bring, which you take to the school, those 15 centimeter, 10 centimeter scales. So if I just keep it near it in this manner, I'll be able to roughly get, because it is not going in depth and it is not a curved surface that it can measure it. So I'll get it rough. But if I have devices like the Vernier calipers, in Vernier calipers, what happens? Have you had your practical classes? Any of you? Not yet?
No, ma'am.
Not yet. So you must be having your classes soon. In the practical classes, this is of prime importance, not only in your class 11 till your class 12. Even the externals who come for your practicals, they check for your errors, because error is definitely there in your instruments. It is there naturally. Error comes in your practical classes and then your results. So you can never get the exact precise result. So for there, we calculate the error. So now what happens, if Vernier calipers is actually an instrument which has two structures like this, which move up and down. And here we insert the thing which we have to calculate. For example, if I had to calculate the diameter of the ball, then I have to put the ball over here, and then by this it will let us know what is the diameter. So what happened? I could have calculated it with meter scale. I would have got an approximation only. No, it's not impossible to calculate it with that centimeter scale. I can just put it in this manner and check it. I will not get that accurate reading, but I'll be able to analyze it. But why am I preferring other instruments which can measure the diameter? Because of the term which you should know that will be utilized throughout, that is known as least count. There's a term that is known as least count, and least count is used in any instrument, I'm repeating, which gives you any kind of measurements. If any instrument that gives you any kind of measurement. For example, if you have spring balance, you must have heard of spring balances. In spring balance, what happens? It gives you the mass of the object. So it gives you a measurement, no? So there can be error in spring balance, and its spring balance has its least count. Now, what is meant by this term least count? Least count means it's the minimum amount. It's the minimum amount of measurement of an instrument. If I say, for example, if I say the centimeter scales that you have, all right, that the small 15 centimeter scales that you use in your school notebooks and all. So there it has markings. From 0 it starts. Some lines are there, then you see a bigger line, then you see again smaller lines, then you see a bigger line. In this manner, whole scale is calibrated till the end. Let's say this point is 15 centimeters. This was 0. It had started with 0. This is the whole scale. It is having certain small lines also. Can any one of you tell me what is the minimum value the scale can measure?
1 millimeter.
1 millimeter, perfect. It measures what? It can measure, see, it is measuring till 15 centimeter. It has calibrations till 15 centimeter. It could have also be measuring 1 centimeter. It does measure 1 centimeter. We also know it measures 2 centimeter also. It measures 3 centimeter also. But not talking about 1 centimeter only. Let's talk about lesser of it. If we look at it, then we are able to see it still measures an amount less than 1 centimeter. That is what? 1 millimeter. Means this very small calibration. Now, can it measure less than 1 millimeter? Yes or no?
No, ma'am.
It cannot measure. It means reason for this is the least count. Least count of this scale, whatever scale I have taken, this 15 centimeter scale, this is least count is 1 millimeter. Or if I want to convert it in terms of centimeter, what did I tell you? Whenever you have to write anything in terms of meter or centimeter, milli has to be replaced with the help of 10 to the power minus 3. This much meters. Or you can say 10 to the power minus 1 centimeters. All these three are what? These are the least count of the scale. So least count means what? It is the minimum measurement of an instrument. The minimum value any instrument can give you. For example, in this scale, 1 millimeter was the minimum value that was possible. Or let's take more example. For example, your wristwatch, or let's say I have taken a watch. It also has calibrations. These bigger lines are there. Starting from 1, 2, 3 till 12, all these calibrations are there, and in every clock they are there. Then you are able to see minute calibrations also. So this clock is able to measure 1 hour. This clock is able to measure 1 minute. This clock is able to measure 1 second. So tell me, what will be the least count of this wristwatch or whatever watch is this? Yes, Aram, you will answer.
A second?
A second, 1 second. The minimum measurement of an instrument. Instrument here is what? Let's say the instrument here is the wristwatch. This is the instrument. So what is the minimum measurement that it can give? 1 second. It can give us 1 hour. It can give us 12 hours even. The clock can measure up to 12 hours. The clock can measure up to 1 minute also. The clock can measure up to 60 minutes also. That makes 1 hour. But the clock can also measure as 1 second. And this is the minimum amount which is possible. There are various clocks which have different least count, which can measure milliseconds as well. So 1 millisecond becomes the least count of that particular clock. So this was just an example, random example that I've taken. But if this clock only had been measuring 1 milliseconds as well, then that 1 milliseconds would have been the least count of it. So the device that I was telling you, which you have not seen till now, Vernier Calipers. I'll show you the pic of it if you want. It's an instrument which has hooks in this manner. Here you insert, for example, a cylinder is inserted to calculate the length, and here the whole readings are given. So as you keep on moving this, as you slide this, you get the length of it, and the length changes from here. In this manner, you have this. You will see this instrument because this is in your syllabus. So least count is what? Least count of Vernier calipers. For now, you can remember it. Least count is what? This is 0.1 millimeters, which is 0.01 centimeters. This is the least count of it. So it means it can measure up to 0.1 millimeters. If the diameter of the, let's say, of the very small bob that I have taken, a very small metallic bob that I have taken is 0.1 millimeters. So if I try to measure it with the help of this scale, no, this 15 centimeter scale, if I put it and try to measure, what will happen? If this ball is so small, 0.1 millimeters, it means if I try to measure it with this scale, I'll be able to only measure 1 millimeter, not beyond this. Reason, the least count of this is 1 millimeters. But if I measure it with the help of Vernier calipers, I'll get it 0.1 millimeters. Let's say the diameter is less than that. For example, then you have a device known as screw gauge. The device is known as screw gauge. This is also a device similar to Vernier calipers, only in this manner you have it, and the calibrations are rolled on it. So, for example, a cylinder or a ball that has been inserted over here, you keep on rolling it and then you get the reading. So that you'll learn in your practicals how to use or apply. But the least count you should remember. Least count is 0.01 millimeters. That is 0.01 centimeters. 0.01 centimeters, this much. It means what? Screw gauge can measure 0.01 millimeter by itself. This is the minimum value. Beyond it, it cannot measure. Above it can measure any amount. Then Vernier calipers, least count, 0.1 millimeter. It means it is the minimum value that this device, this instrument known as Vernier calipers can measure. Talking about the clocks or the common wristwatches that you have, least count is usually 1 second. A watch is able to measure 1 second, which is the minimum amount. And then the scale, that example I had taken here, the minimum amount that could be measurable, that was 1 millimeter. So all these are the least count. Least counts means what? Minimum measurement of any instrument. Is this clear to all of you? Fahad, is
Yes,
it
ma'am.
getting clear?
Yes, ma'am.
Yes, ma'am.
So start noting down from here. Done.
Done, ma'am.
Done, ma'am.
Just a second. Now see, in your devices, you have two more terms with you. Least count is the basic term for calculation. But apart from this, you have two terms known as accuracy and the other term is known as precision. Now, there's a very slight difference between being accurate and being precise. Accuracy you can always say when you are close to an answer. For example, if my answer, I have given you a question. For example, if I've given you a question to all three of you, and the answer is 10.34 centimeters. Any question that I've given you. Arnav says he has got 10 centimeters as the answer, but my answer was what? 10.34 centimeters. So the answer that Arnav is getting, that is 10 centimeters, this is an accurate answer. Means he is correct, no? 10 or 10.34. These are close enough. So accuracy, I'll say Arnav is accurate. Arnav has got the accurate answer. But if Aram says she has got 10.23, then I'll say, Aram, you have got the precise answer. Means what? Precise answer means what? The exact value. Whatever value is there in actual or in reality, that value if you're getting with all the decimal values, with all the approximations kept aside, then you say it's the precision of any measurement. So accuracy means what? Let's discuss first accuracy. Accuracy, it is a measure of closeness of true value. True value means what's the actual value. For example, if I say this pen, the length of this pen is 10 centimeters. I ask you both, I ask you all three to calculate the length of this pen. So Fahad says the length of this pen is 9.9 centimeters. It is coming this much. But what's the value? Actually, it was 10 centimeters. Because of some errors, because of some wear and tear in his instruments, or by some any means, he is getting 9.9. He is close enough. 9.9 centimeters and 10 centimeters. Both of these are close enough to both each of them. So that 10 centimeters, that becomes my true value. Value means what's the actual value, actual measurement. So accuracy, it is a measure of closeness of true value and measured value. true value and measured value. If this difference is very less between the actual value and between the measured value, then I'll say, and then you can say the measurement is accurate. For example, in this example only, it was 10 centimeters. Fahad was getting 9.9 centimeters. What's the difference? There's a very slight difference, 10 centimeters and 9.9 centimeters, 0.1, such a less difference. Then I say the answer is accurate. The calculation or the measurement done by Fahad is accurate. But if some other student measures it as 6 centimeters, then I will not say it is accurate. There's a large gap difference. So the difference between the measured value and true value, it has to be close to each other. And this closeness measure is known as accuracy. Clear? Accuracy is clear? Any doubts till now? Arnav, Veram, Fahad?
No, ma'am.
No, ma'am.
Fahad, what about you? Clear to you?
Yes.
All right. Now, the second term that you have is precision. Precision is the measure of closeness that is measured around the actual value with each other. For example, if I say a person A is there, person B is there. Person A has given me values 1.2, 1.3, 1.4, 1.5, all these, let's say, centimeters. I have given the person an object and I've asked to calculate the length of the object. And A person, he has given me this. A person has given me 1.2 centimeters, 1.3, 1.4, 1.5. Whereas this B person, this person has given me 1.21 centimeters, 1.22 centimeters, 1.23 centimeters, 1.24 centimeters in this manner. So whom should I trust? Will I be able to rely more if I compare the first one? If I compare this one? So will I be able to trust A more or will I be able to trust B more? Whose value should I depend on according to you all? A person who is giving me 1.2 centimeters or a person who is giving me 1.21 centimeters? Yes. Yes, Fahad, you tell us. 1.2 centimeters or 1.21 centimeters?
1.21 because it's more precise.
Exactly, correct. So 1.21, because if you are here knowing the exact value, whatever is the true value, it is closest to it. You can say it is the exact true value. It means B is more precise. This is what is meant by precision, what is meant by being precise, and what is meant by being accurate. It is independent of accuracy. It doesn't depend on accuracy. Don't ever think that precision depends on accuracy. Precision is an independent topic. It is independent of accuracy. It's just that precision depends on the point-to-point minute values of the measurement. So it is the measure of closeness of measured value, closeness of measured value. With each other. And also it is independent of whatever is the true value or whatever is the accuracy. It is independent of accuracy or the true value. Whatever is the true value or whatever is the measured value. Precision doesn't depend on it. Precision is independent. It has its own value and you have to get that exact value with you. But precision does depend on one thing, on the least count. If I say the let's say the length that I'm getting with the help of that centimeter scale only in this example. If I say I'm getting the length of something in terms of approximately 2 centimeters. But if I get this answer in terms of least count, no, my answer will be more precise. It will be more precise than getting 2 centimeters. If I get the answer in millimeters, it would be lying somewhere here. Let's say it would be lying somewhere here in this, or exactly 2 centimeters. So if I get it in terms of millimeter, I'll know that the answer is much precise. It is more close to the actual value because I'm getting in point. If you write 2 centimeters, but if I write millimeters, it will be 9.9 or something in this manner. But if you write it in terms of centimeter, it will be a unit less. So precision depends on the least count. If you are getting 0.01 millimeters as the least count, for example, in screw gauge, 0.01 millimeters. So if the length of something is 5, it will be 0.05 millimeters. So accurate. Can you see that precision? 0.005 millimeters, this much. So it means precision depends on what? Precision depends on the least count. So precision depends on the least count. Now, instrument which have the minimum least count will give you the more accurate measurement. For example, if you have 1 centimeter with you, a scale that can measure minimum 1 centimeter, and another scale that can measure 1 millimeter also. Or not take the example of scale. Let's take the example of watch. You have a watch that measures hour. So after 1 hour, the smaller hand gets changed. Then after 1 hour, again the smaller hand gets changed. The hour clock you have. Then you can get a 1 minutes clock also, where minutes change as it is 60 minutes, then 1 hour gets changed. And then you have a third clock where it gives you seconds as well. That tick tick occurs in that clock. This is because of the seconds which it is moving. And you have one more clock, those digital watches that you have, that gives you the values of those seconds also, milliseconds also. In 1 second, while 1 second has occurred, 2 second has occurred, there is so much milliseconds have already occurred. So out of all these, you will obviously prefer this milliseconds one, because this is giving you milliseconds value, it is giving you 1 second value, it will give you 1 minute value, and it will give you 1 hour value as well. Obviously, you will prefer this. You won't prefer that R1 where 1 hour will pass and then you will realize that 1 hour has passed. You'll obviously prefer the clock that will be having the lesser of the value available. So lesser of the available value is what? The least count. So that's why instruments that have the least count minimum, they actually give you the precise reading. So instruments having minimum least count is more precise. All right, start noting down. When all of you have written it till the last point, just text me done in the chat box. So I get to know that all of you have written it down. So only Aram has to know. Arnav written?
Just last point, ma'am.
Okay.
Yes, ma'am, done.
No, so now all these were just theoretical points. What is meant by accuracy? What is meant by precision? All the basic things that you should know before doing the actual practical and doing the questions. Now the calculation part. How will the questions be coming in your examinations? How to solve the questions? Firstly, how to check the true value. True value means the measured value, true value, or the mean value, you can say. So when you get the true value or mean value, what happens? If you perform calculations, there will be different readings coming whenever you will be practicing it another time. For example, if I give you a scale and ask you to measure the length of this pen, one time you will get it as 9.9 centimeters. Next time you'll try, you'll get it at 9.8 centimeters. One time you try, you'll get it as 10 centimeters. Different values. So how will you get to know what is the value of it? Because see, because of air resistance, certain factors, there will always be a difference in the values whenever you will do the calculations. So if I give you this length, this pen, and I ask you to calculate the length of this pen, every time you are getting the different values. So how should I know what is the length of this pen, or how should you know? For that, you calculate the mean value or this true value. For example, let's say A1, A2, A3, up till AN. These are the N measurements that you have done. And N times you have made measurements. These are the N measurements that you make, A1, A2, A3, A3. That I'm talking you to, 9.9, 9.8, 10. All these let us take in terms of variable A1, A2, A3 till AN. Now, whenever you have to calculate the mean value is calculated the way you have been performing mean or calculating the average value of anything. Similar, I think you have studied this in your 9th or 10th classes as well. If you have three quantities, you take the sum of all these three quantities and divide it by 3. If you have two quantities, you want to find out the average. What do? You add these two quantities, divide them by 2. Similarly, if you have n number of quantities with you, so what you will do? A1 plus A2 plus A3, you will keep on adding all the measurements that you're getting and then divide it by n. That's what is the mean value. Means summation of I is equal to 1 till n ai divided by n. This is just a method to represent it. No need to look at this. Main understand over here. If you're asked to write the mean value, just add all the quantities divided by the number of quantities. That gives you the mean value. Now, apart from this, from here the error begins. First error that you get is known as the absolute error. This is known as the absolute error. For example, let's say you have solved this and you have gotten a value that is AM, means the mean value. Now, absolute error means AM is the mean value, just clarifying. Let's say delta A1, this is the absolute error 1. Now, how do you calculate it? Whatever is this mean value coming, subtract it from the measured value. For example, mean value is AM. Subtract it from first measured value, that is A1. Delta A2, this is AM. Then again subtract. Subtract is what? A2. A2 is the measured value from here. Then delta A3. AM is the mean value that you are getting. So mean value, you first have to perform all the steps. Means you have to take out the average value and then subtract it from the measured value, that was A3. So if you have AN, delta AN, up till delta AN if you are calculating. So this will be what? This will be AM minus AN. So N can be any number, 1, 2, 3 till infinity. That gives you the absolute error. But not only this, you have to sometimes calculate the mean absolute error. So for calculating the mean absolute error, yes or no?
Ma'am, if A3 is greater of value than AM,
you take the
then
modulus. Take the modulus. Do you know what is meant by modulus?
the bigger value?
No. Modulus means whenever, for example, I have 5 minus 3 with me. All right. So this is plus 2. But if I have 3 minus 5 with me, I'll get the answer as minus 2.
Yes, ma'am.
If I write these symbols, these are called as modulus. So if you put mod, what will happen? Your answer is minus 2. So in this case, whenever you write modulus, the sign is never written. That is 2 will always be written. So modulus are there, means you don't have to, even if it is coming out to be negative, like 3 is your AM, means mean value. 5 was your A3, let's say. So it's coming out to be minus 2. You will write it as 2. Because in error, minus plus won't matter. It will matter at the end, when you will be performing calculations, whether it is positive error, negative error, there it will be useful. Otherwise, for your calculations, you have to put mod. Mod means, if anyone doesn't know what is meant by mod is that your mathematics modulus, which you must have studied in your lower classes. If you put modulus into anything, even if I have this number, minus 1, and I put modulus, it will be, the value magnitude will become plus 1. Clear enough?
Yes, ma'am.
All right. Now, if you have to find out the mean absolute errors, you have delta A1, delta A2, all these are absolute errors. If you have the mean absolute, if you want to calculate the mean absolute error, So then similarly, the way you have been calculating or the way you take the mean value of anything, just take the mean value of all the errors. For example, delta A. Take delta A1, take mod of it. Don't forget to add this. So I'm putting the mod only. Then delta A2. With mod means even if it is coming negative, you will write it as positive only. You will write the magnitude only. Plus delta A3 up till mod of delta AN divided by N. This gives you what? This gives you mean absolute error, which is denoted by this delta A bar. Mean means anything's average. So if you have different absolute errors value, if you take out them, if you want to take out their mean, simply add them and divide it by N. The second last type of error, which is a continuation of this one. All these are continuation. No. See, if I ask you to calculate mean absolute error, will the mean absolute error ever be calculated without the help of absolute error? You first have to calculate the absolute error. For calculation of absolute error, will it be calculated without the help of mean value? No, you have to calculate the mean value first. So in this manner, all these are interrelated. So even if the last part like this one, mean absolute error, or the one which we are going to do fractional error or relative error, it has two names. You call it as fractional error or relative error. From here, the calculations become easier. Till mean absolute error, you have to perform a lot of calculations. From here, it gets a little simplified. This is relative error. So in fractional or relative error, take the mean absolute error, which you have got in just the previous part, divided by the mean value. This is how you calculate the fractional error. And if I ask you what is the percentage error you are getting, so this is easier than the previous one even. Percentage error, if you have got your fractional error, multiply it by 100, that gives you percentage error. The answer will come out in terms of percentage only. So whatever the way you answer it, no, in your practicals also you will be writing, or in your this theory papers also, how will you write? You will write it in this manner. Answers with error you will write. For example, some mean value was AM, plus minus you write, because you have different types of error. You have positive error, you have negative error. That we'll discuss it, what is meant by positive or negative. Mostly this is your practicals portion. So your school teachers must be telling you what is positive, negative error. That comes in your viva or your practical exams only. In this theory paper of physics, it doesn't come. This question definitely comes. All the questions based on these formula. Dimensions come. Derivation of formula comes in your subjective exams in your school. Dimensions and conversion of unit comes in your entrances. And this delta A by M into 100 till here, it also comes in your 11th as well as in your NEET and JEE. In JEE also this comes a lot, error analysis. But your theory papers involves this much only from your first and second chapters. So plus, minus, and whatever is the absolute value that you are getting, or mean value plus minus whatever is the percentage error that you're getting. This is the best way to write it. AM plus minus the percentage error. This is how you write. First, note down all the formula of all them. I'll give you a question, then try it with the help on this pattern only.
Done, ma'am.
So a measured value means the true values that you're getting after measurement. So L1 is 1.1 centimeters, L2 is 1.2 centimeters, L3 is 1.3 centimeters. Let's take only 3 readings. Now you have to calculate everything, all the things that we have studied till the fractional error. Means you have to calculate the true value is given to you. You have to calculate this true value, absolute error, mean absolute error, fractional error, and percentage error. All the errors in this. See, first part is very easy to calculate the true value or the mean value. LM, let's say here we have the dimensions as L. So L is the length that you have. So you have 3 values. Mean you have to take. So what did I tell you? Add all the quantities that you have and divide it by the number of quantities that you have. So it will be L1 plus L2 plus L3. What will come in the denominator? Yes, what will come in the denominator?
3, ma'am.
3, because the number of quantities that you have is 3. So this will be 3. So if you add all of them, this will be what? 1.1 plus 1.2 plus 1.3 divided by 3. So this is 5, 6, and this becomes 3. So it is 3.6 divided by 3. This is 0. This is 1.2. 3.6 divided by 3, that gives you 1.2, and the SI unit will not at the SI unit, the unit will be centimeters, because all the lengths are given to you in terms of centimeter only. Fine, this is the true value. Now if you have to calculate the mean value, so you have 3 quantities, we can easily calculate for all of them. The absolute error, see how the absolute error is calculated. Delta L1 means LM minus L1, mean value minus L1. What was the mean value coming? 1.2, and the L1 was given to you as 1.1. This was L1. So minus 1.1. So this becomes 0.1 centimeters. You have delta L1 with you. Delta L2. Fahad, how will we calculate delta L2? Yes, Fahad. How will you calculate delta L2? Absolute error. Aram,
Yes, ma'am.
how will you calculate delta L2?
LM minus L2.
LM minus L2. Clear, Fahad? Is this clear? Okay, it will be LM minus L2. So LM is 1.2 that we have calculated. L2 is what? L2 is also 1.2. So this is 0 centimeters. Then delta L3, this will be LM minus L3. Means the mean value that you are getting subtracted from the length L3 that you have. Now Arnav, you can see L3 is greater than LM. So here you can put it as negative also. It doesn't matter. In an absolute error you can. But remember, while calculating the mean error, don't forget to put that mod. This is 1.2 minus 1.3. Means it is minus, this is minus 0.1 centimeters now. So this will come out to be negative. Now when you are calculating, when you are solving it for mean absolute error, always add the modulus sign. Means 0.1 will be same as minus 0.1 will be same as plus 0.1. Both of them will be positive. Now, if I want to calculate the mean absolute error of all these, so let's stop it till here only because it will get lengthier. First, note down the question and these two parts: absolute error and the measured value. Okay, at least note down. Done.
Yes, ma'am.
All of you.